My name is Kang. This is the talk on the virtual appliance detection. What I'm going to try to tell you during the talk is some of our preliminary efforts of detecting virtual appliance using WebScript. I'm also going to briefly mention some other technique in general to detect virtual machines. This is a joint work with Xiaoning, who unfortunately cannot come to Singapore for both work and visa issues. Now, I'm going to start with a quick introduction about us. First, again, my name is Kang Lee. I'm a college educator. I work for University of Georgia. I'm a faculty there, and I teach regularly the computer security courses. I'm also a member of a team Dissect. I don't know how many of you here play CTF. And if you play CTF, you might run into our team, occasionally. We play Colgate and DEF CON and so on. That's about me. So Xiaoning is he's from industry. He is a senior security researcher. He has been doing malware analysis for more than a decade. My collaboration with Xiaoning is great in the sense that he did all the hard work, and I come here to give the talk. Okay, anyway, let's start. So first I'm going to give a quick introduction about virtualization. I'm pretty sure all of you know about this. This is just for clarification on the terminologies. So I have a picture here, which is an oversimplified version of virtualization. What I have here at the very bottom is a physical machine, which is the silicon, all the devices. Okay, and on top of that, we have this hypervisor, sometimes we call VMM, and then you have the virtual machine run on top of it. You have the guest operating system, and then the applications. Now, one thing I want to clarify about the hypervisor part is that the hypervisor actually comes in multiple modes. Actually, I start here echo. Can you guys hear me clearly? Okay, great. So. In terms of hypervisor, there are really at least two different modes. One is sometimes you can have a piece of software running directly on top of this physical machine. And all this hypervisor does is just to manage VM. So this is what we call a type 1 hypervisor. You can also have basically a regular operating system running there. Then on top of it, you run a piece of software. I guess for most end user, like for example, I run VMware Fusion on my MacBook. That's what we call the Type 2 hypervisor. Now, to make it more concrete, you probably are as a user, you probably use one of these, and I just have a list of virtual machine provider or virtual machine platform provider. I have a list here, and including VMware, VirtualBox. Okay, you gotta have use some of those. One thing I want to clarify is that some of these vendors, they actually produce multiple types of hypervisors. For example, VMware. You have VMware ESX, which is a type 1 hypervisor. It runs on top of physical hardware and then manage virtual machines. And for regular users at their desktop, likely you're using the other type of product from VMware, like VMware Fusion, VMware Player, and Server. Those are piece of software run on top of your Windows, Linux. Then you can run a guest OS within it. Okay. Now, so far, all the description is about virtual machines. And in fact, before I came here, gave the talk, there are actually already people email me to say, are you going to talk about virtual machine or are you going to talk about virtual appliance? So I need to make some clarification about what is virtual appliance. So I use this picture to show what is virtual appliance. Our understanding is that virtual appliance is actually one special type of virtual machines. When we talk about virtual machines, we usually just consider we're going to run some guest operating system, and likely you're actually going to run multiple applications within that guest OS. Okay? You don't really care too much, what's running there. Virtual appliances are some special type of virtual machines. Likely, you really want to run something in isolation. For example, if if you are doing malware analysis, let's say you have multiple samples, you want to run them, you want to test them, you don't want to load all of them in one VM. You want to load one in each individual one, right? So that when you analyze them, there's complete isolation. Okay, so that's one place you want a virtual appliance. Another possibility is that maybe you have an old piece of software. It's maybe running only on Windows 95. You don't want to run any other thing on top of it. So virtual appliance are a bunch of virtual machines that have been tailored to run specific applications. Okay? And this tailoring requires maybe some modification in the VM, sometimes also including the operating system modification and even application stack. For example, if you are doing malware analysis, and you might want to, some vendor actually does this. I couldn't mention the name of vendor, but what they do is they actually lower the protection level in the VM so that they actually can see what's the behavior there. Some other virtual appliances also add the auto it kind of function. If there are any pop-up, they can click it immediately, automatically. So those are the case about virtual appliance. Those are the specially built virtual machines. Now, hopefully with this part clear, now let's go to the real question. Go to the detection about virtual appliance and about why I want to do this, and then how we're going to do this. So why do we want to detect virtual appliance? I want to actually bring up first, talk about a brief overview about why I want to detect VM. Okay, because virtual appliance is really just a special case of virtual machine. So there are actually tons of work on the detection of virtual machines. When Xiaoning and I work on this, initially we tried to actually come up with a list of all the prior work we actually put into a group. There are just so many of the work in the past. Okay, and so I'm going to simply pick one or two few motivation and tell you why people want to detect VM in the past. So this is one of the legit reasons people say why a regular user might want to tell, am I running on a VM or am I running on a physical machine? So in nowadays, like this is the virtual private hosting or virtual private server is so popular. In early days, like when people rent a machine, they actually have consideration about whether they want to have a physical box, dedicated server, or they want to have a virtual one. Okay? And the price are different. But from the end user point of view, when you get into a machine remotely, it's not obvious, at least, that whether you're running on a virtual machine or maybe on a physical one, or maybe you were starting with a physical one, later they migrate you to a virtual one. Okay? So that's one of the reasons people, at least the legit reason, the end user want to detect VM. And I believe one of the Debian flavor, I think it's Ubuntu. They even have a VM detection software built in. Okay, so that's the old day. But nowadays, like the virtual machine are actually getting very powerful. So really, whether you choose a VM versus a dedicated hosting, there's pros and cons in both sides, and it's the demand of that type of detection is not that high. But there are emerging needs on this. For example, in the security area, I assume lots of people heard about the term blue pill. Okay, so blue pill is a concept. This is different from the red pill. Red pill is a way to detect VM. Blue pill is a concept that about a certain type of malware infection. And what this malware infection does is it's going to turn a machine that operating system running on a physical machine and just run a very thin layer of a VM, and so that whatever detection or prevention technique you had installed in the OS before, now it's running in the guest OS. And if the malicious the attacker actually controls the underneath VM, it's a very thin layer that is not really noticeable by the end user, then this malware is pretty hard to detect because your guest OS activities can be monitored, but on the other hand, if you scan the guest OS, you would not find a clue about it. So that's one of the legit demand of detecting virtual machines in general, or maybe special type of virtual appliance, which is on the malicious side. But if you also look from the attacker point of view, there's also a huge demand for them to try to evade the detection, because a device like FireEye, for example, every time they see a PE file or Windows executable on the wire, they might want to run in a VM. They have a specialized built virtual machine, and they want to run and analyze it. So from the attacker point of view, attacker wants to detect whether the code is running in a VM or a special virtual appliance. If they can find that, they can choose to not do the exploitation, or at least maybe delay it. Okay, so from the evading point of view, there's also the motivation of detecting virtual appliance. Now, hopefully you trust that there's demand of doing this. Now let's go to the real question: is how to detect virtual appliance. The short answer is it really depends which type of virtual appliance. Okay. And because virtual appliance is a VM, and for those VM that allow people to run arbitrary program, or maybe even access the GasOS kernel level, life actually is not too hard. Okay, if that's the case for all the virtual appliance, I think I don't need to come here, give the talk, and we just I'll go to the pool. So because there's really a rich set of prior work. And you can really run some special program using instruction like like NOP instruction, look at the behavior. So there's lots of work. Okay, but for other type of VM, for example, the appliance that really try to detect the really only run certain type of application. For example, I have a few picture here illustrate. Let's say 3 kind of virtual appliance. Each of them only run one type of application. Okay, like for example, the first one only run IE init. It doesn't run any other application. In order to run any detection, you would have to, give some web script to let it run. Okay, or you might also have a virtual appliance that only run a JVM. So you can only give it run a Java program or maybe applet and so on, PDF. This is actually certainly a simplified case. In practice, most of the virtual appliance probably going to run a set of application. Like if you want to do malware analysis, maybe you have a virtual appliance actually tailored to run both IE and look at PDF, maybe some of the Office document. But for the simplicity of discussion, I just assume you only run one application, okay? And in all this case, nevertheless, the trouble is you lose the ability to run arbitrary program, like, for example, you want to run red pill, well, it doesn't work. You need, they don't allow you to run your program, okay? There's a program also called VM detect, well, you cannot run it. So you would have to seek other way to deal with this. And we initially saw this, we can do it. This turns out pretty hard. Okay, so we only have some preliminary result here, and Xiaoning also have some new tricks, and unfortunately we couldn't have time to put in his talk, so he's also going to talk about this with additional detail in Hacking Miami in May. Okay, so overall, what we find out is for some of the VM, it seems like we could still do some detection from the application script level by using the display property. Okay? By display property, I mean the display and graphic features. And why we're doing this, why we want to focusing on using this display property to do the virtual appliance detection, it's based on these observations. So first, even for the virtual appliance that only run, let's say, a browser or maybe only run a PDF reader, they still have to expose some of the display property to the VM. Okay, so they always have some display property you can potentially touch. And second part, in terms of virtualization, the support for virtualizing the display part is actually not that advanced. So, for example, you can do PCI pass-through for lots of devices, like Ethernet card, but to do PCI pass-through for video, which I'm going to also mention later, to do it for video, you can do it, but you pretty much need multiple graphic card, and then you do one for each VM. Okay, so that's why we actually try to take this approach. And overall, now I basically changed the goal to say I'm going to try to detect whether I'm running a program, whether that's running in virtual appliance or whether it's running on a physical host. I'm going to use a display property. Now, what are the display property you can use? So there's a few simple ones I'm going to list here. And for example, the very dummy one are some of the display screen resolution information, and including the size of the window and also the refresh rate and so on. There's also the feature we look at whether the VM or whether the application support advanced display function like HTML5 or WebGL. Okay. We're also going to look at the 3D rendering performance through the application. Now, starting with a very simple one. Okay, we start first assuming this is an appliance running Java virtual machine. So we wrote a simple dummy Java program. What this program does is it tries to enumerate all the possible resolutions supported by the adapter. It turns out JVM exposed this to the virtual environment. Java is supposed to do this protection, isolate the physical information from the applet or the Java program, but it does actually fetch this information from X server. So it means like you have to have a display, a server running at the back end, then you run Java, then we were able to grab all the possible displays supported by the lower level host. Now, obviously, if you don't run any X, then our program will get an exception saying that there's no X behind. So we ran this in a few physical machines, and we also ran it on VM. So here, this table shows one simple sample of the output. A couple of things I want to mention. First, it turns out that for the modern day display graphic card, now we actually have most of the systems support tons of resolutions. Okay, so in this particular case, we have like 38. And when I say 38, this is like a combination about the resolution plus the refresh rate. So you might have like 1024, 680, and then refresh rate 56. So it turns out most NVIDIA, AMD chip, and Intel chip nowadays really support lots of those. But if you look at VMware or VirtualBox, for example, we just take this type 2 hypervisor and look at their number of displays supported. VMware supports still a reasonable large number, and VirtualBox actually only supports 4 resolution. Now, certainly all these numbers depend on the version of the software we're running. Like for a different version of VirtualBox, maybe you have a slightly different number. It is not that these hypervisor cannot support more. Okay, you just need more work. Okay? And for virtual appliance, you tend to tailor it down, and you often want to run multiple instances in one. So they tend to not implement that many. And plus, if you look at the display refresh rate, VMware is always running in 64 hertz and VirtualBox in 60 hertz. Okay. We actually also checked other hypervisor, like for example Zen, and like there's even other weird number. Like sometimes you even have just like a refresh rate at 1 hertz. Okay, so the reason again you have all this is because the developer of all this hypervisor need to implement this virtual display card, and they really lack of the motivation and also the effort, try to test all the combination of the display. But on the other hand, the physical box, when you have a display card, the vendor actually try to make sure, you support all kinds of resolution. For example, today it's actually take us like, a few minutes to actually get this thing ready because there's lots of combination of support. Okay, and then sometimes you also see a really weird, display the screen resolution. Like, for example, we saw VMware, they actually support this 1041 by 1041. This is, at least to our knowledge, this is pretty rare because in the regular physical display, we usually have at least the screen resolution is it's usually an even number, not even an odd number. But if someone knows why this happened, let us know. So this is dummy example certainly use in Java. You might say, hey, what if I'm having a virtual appliance not even run Java? Well, again, there are other interface. For example, this here, what I show is that you can actually use JavaScript actually, this is the Adobe JavaScript API, and they export lots of information about display. You might saw that, for Adobe, you only need to know the current window, and that's the application size. But it turns out this API allows you to get all the possible display, the resolution behind. So there's this monitor method, for example, you can get the primary display, which is actually supposedly the host desktop resolution. Okay, and then you can get the size, and there are actually lots more information. You can grab from this, and obviously, you can try to use those information to figure out. So those are just some very simple, preliminary effort we try with the screen resolution. Okay. Another thing we tried is simply try to see if the application we ran, let's say a browser, whether it supports certain function. Now, this came as a surprise to us. We didn't expect this, but it turns out lots of the browser, in order to support the advanced display feature like HTML5, especially WebGL, they need to talk to the driver. And the physical display chip vendors like NVIDIA, Intel, they actually make sure their driver interacts with all the browser well. But if you try, for example, in this case, like Firefox 27.0.1, when we run on Windows, okay, it works, it supports WebGL, but if you take the same operating system, same version of the Firefox browser, you put in the VMware, put into VirtualBox, it just complain, say, hey, we don't support WebGL, something wrong. Okay, and here's actually a screenshot. So if you run on the host, it actually says it support, but the same version, if you run on the VM, it doesn't work. So in that way, this is again a dummy heuristic you can use, in case this thing still happen, and you can write a script and try to grab exception. And if you got exception, something wrong, right? So it turns out that when we try IE, on the other hand, when you put in a VM, IE actually works. Okay, IE actually have it work. So my hypothesis is that when the VMware or VirtualBox, when they develop their driver to support the HTML5 and WebGL, they work on the IE, they make it work, but they didn't test on Firefox. So those are just, again, additional information you can use. Now, obviously, when you use this type of behavior, it doesn't really guarantee to tell you, when you send a program to the other side and run in the machine and come back, if, let's say, you got an exception saying no WebGL supported. If you use that, just use that to say, I'm going to use that to detect whether it's a VM or virtual appliance or not, you're going to have some false positive. Okay, so there's lots of reasons that actually a physical machine might actually not even support WebGL. So one possibility is, you might have a weird display card that really not, supported, or you might have an old device that doesn't support it. And you could also have someone just, unload the driver, wanted to use their own display driver. Okay, so you could have false positive. So in that case, if you want to use the early on the heuristic I mentioned to do a wide-scale measurement of, say, how many people are using, applying this virtual appliance detection, that you're not going to have a very accurate result. However, this thing is still useful in the sense that if you have a relatively targeted attack, someone, it's using probably a state-of-the-art machine, okay? Then when you send some script there, and you are worried about in the middle there may be a device that analyzes your program, then that scenario might work. Okay. So anyway, so that's just second scenario. Let's move on. The third effort we played with is looking at the performance aspect of the the graphic display, through the web script. The reason we do this is based on these observations. So first, smooth 3D graphic displays still often require, lots of hardware support. Okay. The virtual appliance or virtual machine platform we have right now, they all have this thing called 3D add-on. So that's supposed to help you to make, rendering the 3D object faster. But it's actually still, based on our result, which I will show you, some sample, they're still falling behind versus the physical one. Third case, for the equipment that use virtual appliance to detect malicious activities, often they run multiple instances of virtual appliance. So rarely they are, going to seek hardware support to, accelerate the graphic display performance. So those are the observations. Now, for people like, old people like me, I know this, I realize this audience is so young. Old people like me will maybe ask to say, why, do you even want to run 3D on the web script, right? That itself raises a red flag. Well, it turns out the trend is that people are, really building lots of game and activities in HTML5 or, really in the web. So here, for example, there's Quick 3 in WebGL. I only know this once I started looking at this work. I even play with, it's actually runs very smoothly when you, running the browser on a physical machine. So there's lots of game and other activity, are using advanced graphic rendering in the browser setup. Now, what we did is again, I do some simple test. Just run the same Quick 3 game. We look at the frame rate, how fast you can render the 3D display. It turns out on the, this is, I believe, if I remember this correctly, this is on the NVIDIA chip. But if you are running on the Intel one, it's also pretty, similar. The host can render 75 frames per second for the Quick 3. But if you run in a VM, even with add-on, it's, not too bad. It's it's still playable. It's 25. Okay, and if you run multiple instances of this, obviously, things are going to slow down. Okay, and the other way to test this, when you really try to stress the 3D display, is that you can try to let it render multiple objects, because sometimes the hardware, when they support fast support advanced graphic rendering, all they do is they can really parallel lots of things, which is harder, for you to do purely in software. Okay, so we also try to test how many 3D objects you can add on in a particular script, and we can basically in our script we can store 5,000 3D object rendering, and we can still keep 15 frames per second. If you want to keep the same frame per second, the VM really being stressed. Now, how to use this information again? We have all this number, but how to use it? So we came with this strategy. Basically, what we're going to do is we're going to write a script, okay, that dynamically, probably exponentially increase the number of 3D objects we want to render. Okay, and we want to check how does the host, how does the other side respond in terms of frame rate. Okay, now if you have the other side report back to say they can support a few thousand 3D objects and still keep 30 frames per second, we can pretty sure that that is a host machine, a physical host running all this. Okay. Again, let me repeat. What I'm saying is, if the script report back a high frame rate with lots of objects, I'm positive the other side is VisualBox. Okay, and plus you can disguise all this detection using a game. Okay, because the other side can now simply say you are actually running lots of objects, then this must be malicious. You can disguise that in a game. Now, however, make sure you understand that I'm not saying that if I get a small number, either a number of object or low frame rate, I will say that's a virtual appliance. I cannot say that because obviously there's also false positive possible, And because first, you can have a really slow machine. Like, my parents probably still use a very old PC, and I actually tried this to run the same scripts, on the Atom box, which is known as at slow and with less graphics support. And so I get 500 objects, 3D object with 15 frames per second. I also tried like a Qualcomm, a Samsung tablets. You can get 500 object at 30 frames per second. So again, the implication for the detection. You can use this technique to try to convince you that the other side is more likely a physical box. But the reverse of the statement is not true. Like if it didn't meet that, you would have to make a decision. Again, how would this be useful? Depending on the situation. If the attack is targeting some, business, some CEO, and likely he's going to use a powerful machine, regardless of whether his work needed or not, then this might be useful. But if you again try to do a broad study, you would have to, do more, use other tricks. So we're still trying to do more effort on this. As I mentioned, that Xiaoning going to do another talk with extending more technique. So far, all I can say is we're still working on this, but it's not like we're completely hopeless, so I actually move on to make more assumption about what potentially could happen. So really, is how can we get more information about that remote machine so that we can make better judgment? So here, I would have to make some assumptions to say, okay, what if we can get some script to run close to native code? Okay, and the example I'm going to use is ActiveX. Okay. Now, I know lots of you say, hey, who nowadays still want to run ActiveX and, stupidly enable that? And you're actually absolutely right. At least I don't see there's a good reason to do so. However, again, think about if we are talking about evading the detection of some box in the middle of, using virtual appliance to analyze the program. And as far as we know, they actually did lots of work to, first lower the level of protection. So they actually run lots of untrusted code. Second, they also enable this auto click. Okay, sometimes regular user nowadays the warning is so good, so you really shouldn't say run this. But in the virtual appliance, they might run it. Okay, so those are the assumption made. So try to say, okay, if you actually have a virtual appliance does that, then things get much easier. And for people that know ActiveX, it's actually running native code. You can have a compiled object like x86 code and run. Okay? Now, you can do a lot of things once you have the other side run this ActiveX or native code. We actually choose to do something very simple. So we look around and find out that it turns out Microsoft supports this WMI. It's called Windows Management Instrument. And then in particular, there's one object called WBEM. It's called Web-Based Enterprise Management. And allow you, if you get the permission, it will allow you to grab lots of detailed information about the host. Now, obviously, if you know more about ActiveX, there are lots of other exploitation you can do, but I'm stay at the simple side. So here's one script we wrote to deal with this, and this is basically just a new WBEM object, and then from there you can actually do a query to say, give me information about this device, about the the underneath OS and how it view about the system. Okay, so now I only show you part of the script, but that's probably the most important part to initiate. And then you can basically enumerate all the item. Now here's one thing, one sample output from our server side. This is basically we have the ActiveX embedded in a web page, and we send to the remote side. And if they run it, we were able to grab lots of information. For example, here you can see that I have the CPU ID. We can know what the type of board they are, and then all the video information, the graphic display information. Now, if for anyone that actually look at the all the virtual machine platform, if you look at all the device they support, the things are obvious. It's really like the clue are everywhere. This is like if you can run a program on the command line. Okay, so you just like there's tons of information. Like the processor is actually has a virtual box screen there. The board is made by Oracle. So all this information are obvious you can grab. And there's more information. For example, you can also look at the device, how their memory map to the OS, and likely the virtual machine they will do the same type of mapping regardless where you run this. But if you look at the physical box, each of physical box is going to have a really dramatic difference of all this device mapping, the address. So basically, even the virtual appliance, can hide all the strings. I'm not going to say virtual box in anywhere, but the behavior of the memory mapping, they can still modify, but it takes a lot of effort for them to customize. Okay. Now, contrary to that, here's the output. If you run this on one of the hosts, you will see. I only show you part of the output. This is one of the machine we have. It's Intel one, and I only show you partially the output about the device, the memory mapping. It's really a much longer list, much richer set of device, and it will take a lot of effort for the virtual appliance or virtual machine vendor to really mimic this as a real device. Now, as I mentioned earlier, like what if on the virtual machine or virtual appliance side, they try to hide all this information. They can choose to say, instead of load the virtual box display driver, how about let's load the NVIDIA one? Well, that naive approach doesn't work because if you load the NVIDIA driver going to say, going to need to access the device. And the device actually is built by, let's say, VirtualBox. Then the driver going to fail to load. So it's not easy for them to lie about it. There is an alternative. The virtual machine or virtual appliance vendor, they can actually try to mimic, like build a virtual device that completely, behave the same as, let's say, a popular graphic card. Okay, so that's a possible approach, and in that case, they can use the NVIDIA driver. Then when you list all the device, at least from the display part, it's we don't have at least VirtualBox information there. It's not easy to grab that. However, this is pretty hard work. Okay, first, as far as we know, there are really now we don't see any implementation of virtual display card that map to the latest or the modern, we don't have any virtual device implementation for display card for modern display device. If you look for, like, say, for example, QEMU or maybe VMware VirtualBox, you can find some old VGA device. I think Cirrus Logic is one of them. This is really, really old display device. Okay, but what I'm saying with all this doesn't mean that they cannot build it. They can still build it because if you look at what are the other devices they build, they actually, if you open up, VirtualBox or VMware, they actually already mimic other devices, right? So, for example, on the NIC, a very popular one is the Intel E1000. Okay, there are, when you run VirtualBox, your machine doesn't have to have an Intel E1000 to run VirtualBox, but VirtualBox mimic that. Okay, so there's tons of devices they can do. Okay, so I'm not saying they can now implement that one really mimics the Intel display or the NVIDIA display or whatever. However, it's really difficult. I can claim that it's really, really difficult for them to make sure that device behave the same as the physical one. And since there's no one implement the virtual, a good virtual display device, I gave you example, from our prior work, looking at the network with the virtual device versus physical device. So here's the example when we look at the virtual implementation of Intel E1000 and we compare the real device. There are lots of behavior difference. So this is one sample we look at. This is based on the QEMU implementation. And for example, if we do a write to this ICS, which is an interrupt cost set register, the physical one and the virtual one actually behave differently. Okay. There's another one. This is about the MDI control. When you gave a value, it's again have different behavior. The point is that when you implement this virtual device, especially the complex device, it is so hard to make them really behave the same on all the corner cases. And we have, last year we have a black hat talk on exactly the topic on how to find the difference between those. So I'm going to refer you to that. Now, you might still say, okay, what if we just use a real device? How about we do PCI pass-through? Okay? PCI pass-through, as I mentioned before, it's popular for some of the device, but so far not yet ready, for the display. But the general concept is that instead of emulate a device like I show on the right-hand side, you have the physical device and later emulate device. PCI pass-through basically, through the hypervisor, expose the device directly to the virtual appliance. So if you want to test to say, is this the real device or not? It's supposed to behave all the same like the physical one because it is the real one. However, based on our current knowledge, so first, there's no practical product that we can access. There's NVIDIA have a product announcement called, there's a device called Grid K2. Supposedly, this is one graphic card. You physically plug in, then they can expose multiple, PCI pass-through graphic card to multiple VM. Okay, and so far we haven't accessed that. But even they made that, let's say it works perfectly, and based on our past experience with the Intel network card, okay, so Intel 10 gigabit and 40 gigabit, which is coming, they actually have different driver for the one that running on the host one and the one running on the VM one. The host one is called PF driver. The guest OS actually ran the VF driver, even they're talking to the physical device directly. So we still feel like even with the NVIDIA K2, likely we might still be able to find some difference. Okay. Now, those are a quick overview about what things we poked to try to tell the difference between physical and virtual. Now, how to really resist this? Obviously we have to look at this thing from two sides. Now, what I want to say is that if the user or the remote side have access to application level, or have access to the kernel level, or able to run native code, our view is that it's pretty hard to prevent the other side to figure it out, okay? Because it's so hard to make the physical and virtual look the same, even if you have lots of hardware virtualization to support this. Now, if you want to limit the scope to say, okay, what if we focus on the old virtual appliance only support web script or application level script? It's possible you can hide lots of the VM specific information, but timing and performance wise, that type of detection is relatively harder to do. So, and also it's pretty challenging to prevent the targeted attack. Like if someone know that the target is using certain type of machine, at least high end, it's pretty hard to again resist that type of detection. Now, to summarize the talk, what I told you is that we did some preliminary effort to try to detect virtual appliance, and we focus on the detection through the web script. Using the web script, you can get lots of display-related information, and those are some simple heuristics you can use. We also look at the case that if you actually have a virtual appliance that run potentially native code like ActiveX, then potentially you have more information you can collect. Or if you have lower level access to the device, then it's much easier to tell the difference. the reason we use display information, I want to reemphasize this, is because the display information often has to expose to the application. Even this is really for a specialized case like Adobe or browser. So there are many properties potentially can be used, and especially the performance side. Okay, with all this, I'm ready for questions. Just go ahead. Yeah. Right. So when you try to run Java code, through JVM, so there are usually, two level of protection. One is they will actually try to say, like say applet case, they will say, has this applet been signed, right? So it's up to, from the attacker point of view, it's up to them to figure out how to sign it. Okay. The second case is certainly the third level of access to simply say, don't run any of the Java applet. So if that's the case, then you will not be able to grab any information. But again, if you believe you can have a site that the end user actually likes to run, and they will see the applet, and if you know they're going to run it, likely you can have the setup let the virtual appliance also run it. Okay? So and also if they don't run, you actually get the exception. Now what that exception means, I don't know. Okay, basically you have to maybe change to a different technique. So that you cannot, because the way we detect virtual machine versus real machine is actually try to say the real machine actually runs faster. So unless you can make the clock faster, right, it really makes things run faster, then you can defeat this detection. Right, slower already indicate you're likely not the real one. So make it more slower doesn't help. Maybe I misunderstand your question.
Yeah.
Go ahead.
All I'm saying is if you run the virtual machine at the speed where you can handle the requests, and if you're using local time constructs, then as far as you know, with a virtual machine, you're running at normal rates.
Right, but see, when you look at the timing and performance, we actually know the physical machine actually can render the box much faster, right? When you try to use a virtual appliance, all you can do is slow down. You cannot go faster. Right. Okay. I got it. Okay. Right. Okay, I got it. So if you actually already intended to know there are the script potentially are using time information, and you can try to lie about this because you can play with the timing. Yes, then you might have to create the illusion that you're rendering much faster. I don't have a direct response about that. Now I understand the technique. So I guess I will have to think more about this and to see whether this completely breaks the approach or not. Sorry, can you repeat the question?
For VM detection for the non-X environment. Do you have any other detection method that you can suggest for the non-X, non-graphical environment?
Let's say let me make sure I understand the question. So the question is, if there's no display, can you still detect, right?
Now, if let's say you are not activating X, so you are in just the text mode, is there a way you can detect the VM?
Right. So again, if you have any way to run, like in terms of in general for VM detection, if you can run the application level program, there are really lots of ways. For example, I believe Xiaoning going to talk in a different presentation. For example, if you look at how the NOP instruction get executed, okay? So in the physical machine, the NOP instruction is really a special instruction. But for hypervisor, the NOP instruction is going to be treated maybe differently. So all you need to do is find all those subtle differences. So I have to understand the particular, virtual appliance, what can they run? Then we can say, okay, are there any clue we can use?
Have you tried to alter the default before from the configuration setting of the VMware, VMbox, whatever it is?
Right. So we are right now limited. The study right now we have certainly tried like VMware, Zen, VirtualBox. Okay. We want to actually extend to more of the hypervisor, and we also want to access more of the virtual appliance. So if you have, if you want to, give us some access, I'll be more than happy to look at that.
Thank you.
Using your current approach, what is the kind of false positive you have in detecting?
That part, I don't have the number now. Okay, so again, this is quite preliminary effort. And I guess in terms of false positive, I would say, we have to look at specific target. Let's say, maybe you want to say, what is the false positive to detect VirtualBox-based appliance, or maybe even more specific to say, what is the false positive to detect if FireEye in the middle? So that, if you want to get any meaningful number, that has to be, I would say, pick a particular target.
So am I right to say that this is not kind of 90% reliable or things like that?
I would say, right now, what we propose, I will have to be honest that I would say, if you want to do a generic type of detection, if you can grab the screen resolution, assuming let's say VirtualBox VMware didn't do anything special, that part you can detect very precisely. But if you talk about using like timing and the support of the WebGL, I'm not going to be say a confident number that high. Okay, I will go much lower. But then again, I keep mentioning that if you have the targeted attack, if you already know this, this is a guy running an i7 box, and I just want to know whether in the middle there's some other machine to protect this target, then I think you can get very high accuracy.
Actually, that's my next question. So, how useful that method can be if you use it for not for a targeted attack, because there's a lot of different appliances and variety of stuff, so you need to check so many things.
Yeah,
so that would be a explosion of the code.
Right. How useful the current one? I would say, if you want to build a tool immediately using this, I won't recommend that because I don't think it's mature that level. However, I do feel like hopefully this is something encouraging people look at, and especially people know more about the display part. Okay, so that will be my response.
Thank you.
You're welcome. Any more questions? Why? I know I'm standing between you and the lunch, so enjoy. Thank you.